In this section, we are going to talk about inverse functions. So we just learned about function compositions, and now what inverse functions are going to be these types of functions that possess very nice properties. And this is going to be really useful when we talk about exponential and logarithmic functions. So before we talk about inverse functions, I still want to talk about one-to-one functions. So this one-to-one function, basically what it means is a function is one-to-one if each value in the range corresponds to one element in the domain. Okay, so one-to-one functions, so all it is just a function is one-to-one if each value in the range corresponds to one element in the domain. Okay, so for example, let's start thinking about what domain and range were. So a range is basically, think about the y values. We're thinking of all the y values. So each y value corresponds to only one x value. Okay, so one y value for one x value. So one y for one x. Okay, so that's basically what it means. Now, if you get confused with what does this exactly mean and how is this different from functions, well, inverse functions are already functions, and all we just need to figure out is that one y value corresponds with one x value. And one way that we can do this is using something called the horizontal line test. Okay, so here is my horizontal line test. And basically what it is that if I give you a graph, kind of like this one, I'm going to use a horizontal line, and the horizontal line can only go through it once. So basically, for one y value, so one of the y values only corresponds with one x value. So if I draw a line, you'll see that for every y value, I only have one x. Right? It's only going to cross one. So this one is one-to-one. Okay. What about a circle? Well, a circle, first of all, is not even a function. Okay, so it doesn't pass the vertical line test. Is it one-to-one? Well, sadly, it is not one-to-one, because if I draw horizontal lines, it crosses through multiple points. So this is not one-to-one. Okay, what about a parabola? We know a parabola is a function, but is it a one-to-one function? The answer here is no, because if you do horizontal lines, it crosses a parabola two different times. So this one also is not one-to-one. Okay, so that one will not be one-to-one. Okay, so now usually what we can do is that we can kind of restrict the domain, okay, which basically means that in the parabola, I can just choose one part of the parabola and not the other part. And in that part, if I say that all my x values are greater than or equal to 0, basically I'm restricting this so I don't have this other part of the parabola. I got rid of it. So if I do that, well, what happens is that now this thing became a function. I'm sorry, this thing became a one-to-one function, because now it's only crossing it once. So in this case, now it is one-to-one. So sometimes you can do these little restrictions, and you'll see that a lot in trigonometry if you end up taking trig. Okay, so what is so nice about these inverse functions? Well, inverse functions. What is so nice about these one-to-one functions? Well, if a function is one-to-one, then the function has an inverse. Okay, So if I know that this function is 1 to 1, then this function has an inverse. So let me give you an example of what does it mean to have an inverse. Well, if you have a function which basically says every x value, I'm going to add 5. Okay? So every x value, I'm just going to add 5. Well, what is the inverse of that? Well, every x value, I'm going to subtract 5. That is the inverse. And the way that we write the inverse is the following way. F to the negative 1. And not to be confused to the negative 1 power, it just looks like that. But this thing with the negative 1 just means inverse. Okay, so that is basically the opposite. So you're undoing the function. Okay, so if you kind of want to look at it a little bit more numerically, let's say this is the domain. So basically all of my x values. Here is my range. It's basically all my y values. And let's say you have little sets. So let's say you have the numbers 0, 1, and 2. You have these buttons, 3, 4, 5. Okay, what this says is that when I click on 0, this is going to go to 3. When I click on 1, this is going to go to 4. When I click on 2, this is going to go to 5. Okay, so every member in the x's in the domain is going to correspond to one member in the y's, the range. Okay, now that since this is 1 to 1, because only one y value corresponds with one element in the x value in the x region, so that means I can easily go back. If I click on 3, okay, I'm going to go back to 0. 4, I'm going to go back to 1. 5, I'm going to go back to 2. So if I were to look this as a coordinate, this will be 0, 3, because x is 0, y is 3, 1, 4, and 2, 5. Okay? Because these are all my x's and here are all my y's. Now, if I was looking at it on the other side, well, now this one is flipped. 3, 0, 4, 1, 5, 2. So now these are my x's and this is my y's because everything is now flipped. Okay? So my question here is, how do we find an inverse? So if I give you a function, and let's say it's a lot more complicated than what f of x equals x plus 5, which was really easy because that's just x minus 5. Well, how do we really find an inverse? Okay, if we got something a little bit more complicated. Well, here are a series of steps. Well, the first thing that you want to do in order to find an inverse, you want to replace f of x with y. Okay. After you replace f of x with y, you want to switch x and y. So you want to switch, so wherever you see an x, it's now going to be a y. Wherever you see a y, now it's going to be an x. Okay, my next thing, solve for y. And finally, replace y with f inverse of x. Okay, so these are directions. If you want to pause the video, pause it if you'd like to write this down. A little note for you: if f inverse of f of x equals x and f of f inverse of x equals little x, then you did the problem correctly. So basically, if you want to know if you got the inverse correct, well, all you got to do is just basically plug in the original function into the inverse, and you have to get x. And then the other one, plug in the inverse into the function, and you also have to get x. That's how you know if you got it correct. Okay, so let's do a couple of examples so that you can get used to finding these inverses. Okay, so here's my example, and what I want to do is find the inverse. Okay, Okay, so here is part A. Let's say we have f of x is equal to x plus 5, since we just did that. Now we know the answer should be x minus 5. Now let's just follow these rules to see if you actually get x minus 5. So the first thing you want to do is replace f of x with y. So this f of x is going to turn into a y. Y is equal to x plus 5. Okay? My next step is that I want to switch x and y. So this x is now, and this y is now going to be an x. This x is now going to be a y plus 5. So I basically swap them. Okay, and now all I got to do is solve for y. Okay, so let's minus the 5 to the other side. So we're going to get y is equal to x minus 5. And now this is not the answer, because we have to make sure that we replace the y with f inverse of y. F inverse of x. So it's going to be f inverse of x is equal to x minus 5. Okay, and that is my answer. Okay, let's do another one. Let's say we had f of x is equal to x cubed plus 3. Okay, so the first thing that we want to do is replace this f of x with a y. So y is equal to x cubed plus 3. Let's move the 3 over. Whoops, I forgot something. Forgot to switch the x's with the y's. So this is going to be an x. This is going to be a y. Okay, now let's move the 3 over. So you're going to get y cubed is equal to x minus 3. And now you're going to cube root both sides. Get rid of that cubed. You're going to cubed root, and you only allowed one cubed root. So y is equal to cubed root of x minus 3. All right, and that's my final answer. Okay, so let's do 2 more. So let's say part C is going to be, I don't know, f of x is equal to the 5th root of 3x minus 1 plus 2. Okay, and then part D will be f of x is equal to 1 over x minus 6. Okay, so first this one, let's change this to y, the 5th root of 3x minus 1 plus 2. I'm going to swap them. This is going to be an x. This is going to be a y. Cubed root of 3y minus 1 plus 2. Okay. Now I'm going to move the 2, because I got to solve for y. So move the 2 over. So x minus 2 equals the 5th root of 3y minus 1. How do I get rid of that 5th root? Well, I can raise both sides to the 5th power. So you get x minus 2 to the 5th power equals 3y minus 1. No need to FOIL everything. Let's just add the 1 to the other side. So you're going to get x minus 2 to the 5th power plus 1 equals 3y. And then finally, we're just going to divide everything by 3. So y is equal to x minus 2 to the 5th power plus 1 over 3. Okay, and all we got to do is change this to f inverse of x. X minus 2 to the 5th power plus 1 divided by 3. Okay, and that's the answer. Okay, so in the next video, I will do part D since I didn't get to that one. And I'll do one that's a little bit more complicated. I don't think I'll test you on that one, but who knows? Maybe I'll give it as a challenge. But I'll show you in the next one.